Let us see this question today. If p term of an arithmetic progression is q and the qth term is p, then prove that its nth term is p plus q minus n. So the pth term of an arithmetic progression is given as q and the qth term of an arithmetic progression is given as p, and we have to prove that nth term. So here we are going to use the same nth term general formula, a plus n minus 1 into d, and here a represents the first number and the nth term n minus 1 times d. D is the common difference here. So let us take the first equation and apply in the nth term. So the pth term of an arithmetic progression is q. So if the pth term is q, means in terms of general formula we can write it as a plus p minus 1 times d is equal to q. This is the first equation, and the q term is p, which represents a plus, in the place of n we'll be substituting with q, minus 1 into d is equal to p. This is the second equation. Now by subtracting both the equations, if you subtract both the equations, 2 from equation 1 will be a plus p minus 1 into d minus a plus q minus 1 into d, which is equal to q minus p. Now expand it and simplify. A plus pd minus d minus a plus qd minus d, which is equal to q minus p. A plus pd minus d minus a minus qd plus d, which is equal to q minus p. Now plus a and minus a becomes 0, plus d and minus d becomes 0. We will have pd minus qd, which is equal to q minus p. So d is common, we can write it as p minus q, which is equal to q minus p. So d will be q minus p, and bring the p minus q to the other side. So it is equal to negative 1. So the common difference is negative 1. Now substitute any of the d value in any of the equations. We'll get the a value. So I'm substituting in the first equation. So the first equation, it is a plus p minus 1 into negative 1, which is equal to q. So a minus p plus 1, which is equal to q. We can rearrange and write it as a is equal to q plus p minus 1. This is the a value. Now we have to prove that the nth term. So apply both a and d value in the nth term, which is a plus n minus 1 into d. This is a general term. The a value is q plus p minus 1 plus n minus 1 into d is negative 1. So simplify this, q plus p minus 1 minus n plus 1. So minus 1 and plus 1 becomes 0. So q plus p minus n. So this is hence proved. We have proved the nth term.